So what we actually did is kind of the work. Here's a kind of image classification problem, and of course the data set we made use of is called cats and dog image classification dataset, publicly available on Kaggle repository. So the first thing we did actually was to get the data set. So then next to that is to import all our dependencies, the libraries that we'll be making use of in the course of the work. So these are the libraries that we can see on the screen. Random Keras. So most of the libraries were from Keras that is built up on TensorFlow. So this is the importation that we did, the libraries that we actually made use of in the course of this research. And of course, so personally I like using warning filter warnings now. So it's just to suppress any Python warning messages, as you can see on the screen. So that's exactly what we did there. Then next to that is to come up with a function. We wrote a function for generally data preprocessing, because the images we downloaded, they have different sizes and with different kind of colors and stuff like that. So as we can see, the name of the function is to get train. So it can be given any name. So we use get train, then we pass the folder as a parameter to it. So what we're trying to do is to get an image from that path, which is the folder. Okay, and then do a kind of preprocessing. So one of the preprocessing is to resize the image, because they have different sizes, and of course to be able to, we have to scale the sizes down so that it will reduce the training time. So for the network, so that's what we did there. And of course we have two classes, which is cat and dog. That's just basically what the project is about. So it's a kind of binary classification problem, where we want the model to be able to predict whether the image given to it is either a car or a dog. So, and that is what we did. And of course we also did a kind of normalization so that the network will be able to train with high level of stability, and that is why we did that, as we can see on this line where we have image where we divide each of the image pixel by 255, just to make sure that the value ranges between 0 and 1. So that's what we did there, and that's what that function is. And the function, of course, is actually returning a list of the image list, the values, and of course the label list. So with that being said, then next to that is the loading of the images, and of course we apply the function, the preprocessing function, to both the training and testing sets. And of course it's also important for me to state that the image is already split into two different sets. So the first set is the training set, and of course the second set is the testing set. So each of these sets have their own folders separately. So, and that is what we actually did here. So the training, we got the training, and of course we got the testing from here, as we can see. So that's what this particular portion of the code is actually doing. And when you go down, you will see that then next to that, because we have preprocessed the data, we have loaded the data, and of course it's already split into training and testing sets. So next to that is to actually design our convolutional neural network model. So this is the architecture here. So we imported the sequential class, and of course we have we added about 3 convolution layer. This is the first one, this is the second layer, and this is the third layer. And of course we to each of these convolution layer we added a max pooling layer. So to each of the convolution layers. So then after that we flatten it, and then we added 2 other layers. So they call it dense layer, fully connected layers. So the first dense layer, we after more trial and error, so we're able to get this thing working. So with the first dense layer having 64 neurons, and the second dense layer, which is the final layer, of course, has 2 neurons. So starting for cat or dog. And of course we use sigmoid function because it's a kind of binary classification, so that is 0 or 1, where 0 represents the the class or category, and then 1 represents the dog category respectively. Then next to that, after we have done our design, then we need to compile it. So by using the compile class, and then we pass all these parameters to it, talking about the optimizer. So we use Adam. Then the loss function is binary concentric because it is a binary classification, and of course the matrix we use is accuracy. Then after compiling the model, the next thing is to actually train the model by calling on the fit class and passing all these parameters to it. And of course I think it's important to state the number of epochs. We train it for 200 epochs. Okay, and that is what actually gives us the accuracy, precision recall, and F1 score that we actually think we wanted. So then after training for 200 epochs, so we evaluated the model, and we calculated the matrix. So we calculated the accuracy, the precision recall, and of course the F1 score. So how do we do that? So we made some prediction on the text data actually. So then we pass that to calculate the accuracy. So we have already imported the matrix from all the dependencies, right? So then the accuracy score, we calculated the accuracy score, the precision recall, and F1 score. Then we printed them out, as we can see on the screen here. So they are printed here. Then next to that, as part of the evaluation process, we also plotted the training the training and the validation losses. So it's also important so that we'll be able to monitor that, okay, this is the losses, how the losses actually reduces in the course of the training. So we did that, and of course we also plotted both the accuracy and the validation accuracy as well. Thank you.